Hi friends, this is Ashish. Once again, welcome to my YouTube channel, Pragyan. Thanks for the support that you have given me, and sorry for the inconvenience related to the sound system in my last video. And here I am with you with my new video of OSTT 2016 answers of physics questions to the needy students who are preparing for OSTT 2019, and make sure to hit the bell icon for better notification PDF given in the description box, and hit the bell icon after subscription so that you can get the notification of my channel's progress. Thank you. Let's the first question of this module. It is from the famous Young's double slit experiment, and we know from Young's double slit experiment we get alternate bright and dark fringes of equal width, and the fringe width is the distance between the two consecutive bright or dark fringes, and is asked about what will be the fringe width in the next case when the slit width is halved and the distance between the screen and the slit is doubled. We know that the fringe width in case of Young's double slit experiment is beta equal to lambda d by capital D by small d. Capital D is the distance between the slit and the screen, and small d is the distance between the two slits. So in the second case, what happened? D2 becomes D1 by 2 and capital D2 becomes 2D1. So with as lambda is a constant, so beta is directly proportional to capital D and inversely proportional to small d. So beta 2 by beta 1 equal to D2 by D1 into small d1 by d2. So beta 2 becomes 4 beta 1. In case of Young's double slit experiment, we get this type of bright and dark fringes, like dark fringes, then bright fringe, then dark fringe, alternate bright and dark fringes. Okay. The next question is the second question. We know that motion in a vertical circle is non-uniform circular motion, but motion in a horizontal circle is uniform circular motion. If we let theta is the angular position or angular displacement, then what will be the angular velocity? Omega is d theta by dt. And what will be the angular acceleration? Alpha equal to d omega by dt, or d square theta by dt square. So we know in case of circular motion in horizontal circle given in the question, the angular acceleration becomes 0, which is in case of uniform circular motion. That's why, so there is only linear acceleration, that is a equal to v square by r. So as the mass is moving around the circle and its displacement is perpendicular, its displacement is perpendicular to the force. This angle, this displacement is perpendicular to the force. So work done in class will be force into displacement, that the angle is 90 degrees, so cos theta becomes 0, and the once work done becomes 0. Okay. So since the distance of displacement where the object and the force direction and are perpendicular to each other, therefore no work is done. The next question, it is from one-dimensional motion of a body at constant acceleration. I have told you in my last video, unless it is given the motion is under constant acceleration, then you can't apply the laws of motion. But it is given one-dimensional motion with constant acceleration, so you can apply the equations of motion. We apply v equal to u plus at t, given the initially at rest, so u equal to 0, then v is proportional to t, as given a is constant. But we know that from of force F equal to ma, that's why m is a constant and a is a constant, so force becomes constant. Then from the given relation, power is given by force into velocity F into v, so F is ma and v is a into t, so m square t, as m a both are constant, so p power varies directly proportional to t to the power only 1. Okay. The next question is from the famous Archimedes principle, which says the mass of a man that floats in the boat is the volume of the water displaced into density of water. So we can calculate the volume by multiplying length and breadth and density height. Here height is the boat that sinks in the water, and density of the water, all are given, so you can multiply the length and the breadth and the height of the boat that sinks in the water the density, so that you can calculate the mass of this question. Remember to convert all the units into SI units. So centimeter is converted to into meter, that is 1.2 and 10 to the minus 2 meter. Okay, and the answer will be 72 kg. This is the question from velocity of sound in gas. I have told in my last class or last lecture video that velocity of sound in air is corrected by the Laplace. So Laplace introduced a term gamma in the Newton's formula, that is velocity of sound in gas is V equal to K adiabatic by rho whole root over. So K adiabatic is gamma into P by rho. P is the pressure and rho is the density of the gas. So if the temperature of the gas remains constant, here the question must mention about the temperature. Here if the temperature of the gas remains constant, then by Boyle's law P equal to constant. So we can put V equal to m by rho, then P by rho is a constant as given m is constant. So if the pressure changes from P to P dash, then the corresponding density also changes. So that's why P by rho will remain constant. Then in the Laplace formula, P by rho is constant, gamma is constant, so V is constant. That is velocity of gas is constant. If we increase or decrease the pressure, it will not affect at all. So velocity of sound in gas is independent of the change in pressure, provided the temperature remains constant. And the extras are the velocity of sound in air is increases by 0.61 meter per second per degree centigrade rise in the temperature. It's given by Vt equal to V0 plus 0.61 T. Here V0 is the velocity of sound at 0 degree centigrade and T is the temperature rise. Okay, and we know velocity of sound in air is inversely proportional to the root over of density. And this is the most important point: sound travels faster in moist air than in dry air. The cause is given here, because in case of moist air humidity increases, and so that water vapor increases and hence density decreases, and velocity depends upon the inversely proportional upon density. Question is from potential gradient. We know that electric field is negative potential gradient. When a gradient will come, then we must differentiate the quantity with respect to the distance, or with respect to the area, or with respect to the volume. So electric field is the negative potential gradient, that is E equal to minus dV by dx. And also we know that electric field is the force experienced per unit test charge. So we can compare these two results by dV by dx equal to minus A by Q. That's why F is given, Q is given. We can calculate the potential gradient, and the answer will be minus 5 into 10 to the minus 5 Newton Coulomb inverse. The next question is from dispersion by prism. We know that this prism has the material whose refractive index is mu, and the relation between mu and angle of prism and the angle of minimum deviation is given by mu is equal to sin A plus delta m by 2 whole divided by sin A by 2. We all have remembered this formula in our intermediate. So here given the equilateral triangle prism, so A is the angle of the prism is equal to 60 degree. So putting A equal to 60 degree, and given it has given cleverly the value of mu as 1.414. Remember that 1.414 is the value of root 2. So mu is equal to sin A plus dm by 2 by sin A by 2. So A is 60 degree, delta we have to calculate, mu is given 1.414, that is root 2, and you can manipulate this result to calculate the minimum value of deviation. Delta minimum will be given by 30 degree. Magnetic effect of current. If we pass current through two wires placing parallelly, then there must be a force between them, and the force is given by mu naught I1 I2 by 2 pi s, where s is the distance between the two wires. So first of all we have to calculate the field exerted by the first wire on the second wire, that is the magnetic field B produced by current I1 in the first wire carrying at a point on the other wire which is parallel to the previous wire is B equal to mu 0 I1 by 2 pi s, where s is the distance between the two wires. So the force exerted per unit length will be this. You have to remember this formula. So answer will be mu, as the current in the both conductor is I, so mu I1 I2 is equal to mu naught I square. Question is from a transformer. For an ideal transformer, the power input is equal to the power output. That is, total power remains constant. The power, how much power in and how that much power out. So we know that power formula is V into I. So V in the primary into I in the primary is equal to V in the secondary into I in the secondary. So putting all these values, we can calculate the primary current, and it's given by 0.5 ampere. Next question is from capacitance. I think this problem we have all done in our intermediate. That is two parallel. That is the equivalent capacitance of two capacitors when connected in series and when connected in parallel is given. We have to calculate the values of the capacitance of the individual capacitors. So as they are connected in parallel, so C becomes C1 plus C2, and when they are connected in series, C becomes C1 into C2 by C1 plus C2, and these are given 16 microfarad and 3 microfarad respectively. By manipulating these results, we can calculate the value of C1, C2. We can proceed the result by two ways. Either by I have given the first way, and you can calculate by other method by using the quadratic equation form. Okay. So from this equation we can calculate the value of C1 into C2, which becomes multiplication of C whole into C1 plus C2. That is C1 C2 becomes 48 microfarad, and C1 from equation 1 we can calculate the value of C1 from this equation. C1 equal to 16 minus C2. So putting equation 4 in equation 3 becomes 16 minus C2 whole into C2. This becomes, so we can calculate C2 from here, then we can calculate the value of C1. Okay, this is easy.